Hey everybody, wanted to do some more on lab scopes, and we're going to get into computer input signals. This is going to be on the automotive side, not to be confused with the other signals, which are pretty close to the same. So let's go ahead and get started. All right, input signals, there are going to be 5 basic ones. I'm going to be talking about your alternating current or your AC signals. Then we're going to get into the direct current, your square waves, and then your fixed digital pulse width, that we actually talked fixed digital pulse signals that we kind of talked about in a previous introduction, and then pulse width modulated signals, and then we'll finish it up with some serial data signals. This was so you understand what they look like. I'm going to give you some examples too. So the alternating current changes the amplitude and frequency respect to the time alternating. The signal goes above and below zero, and this is going to be your complete, alternating current. So it's going to be negative and positive. And so this is going to be like in your pulse, your magnetic pulse generators, in your, distributors, your trigger for your cam, crankshaft position sensors, wheel speed sensors, which is part of the ABS. And then also your piezoelectric, like your knock sensors, and also your detonation type sensors, which pretty much are, same kind of, but they just name them sometimes differently. So this is an example right here. This is an alternating signal off of Ford crank signal. This signal is alternating, so it's not a square wave. It's going to be an alternating, and you're going to see that it has, if you measure it up between the two parts right here and here, you're going to have like 35 teeth to it. They're about 10 degrees apart, and there's one missing. Instead of being 36, there's one missing, and that one tooth that is missing creates that pattern that you see on the screen. And this tells the actual computer that, hey, I've got number 1 coming up, and depending on the make and model, you'll actually have some of them doing that at certain degrees too. So this is a good example of using an alternating current for like a crankshaft sensor. And then here's a Toyota. This is another one with a crankshaft sensor signal, and it's similar to the one before, but you can actually see that this has that actual tooth missing again. And then our direct current signals, they will be above zero. So remember, alternating currents go below zero, so you're going to have your positive and negatives. So these voltages stay above zero. You have them on your battery voltages, your PCM reference voltages, coolant sensors, air temp sensors, throttle position sensor, air vane flow sensors, your mass airflow sensors on some of the vehicles. And there again, you can actually have it on map sensors, but kind of Ford's a little bit different on theirs. And then this is a typical, like a throttle position sensor. It could be an EGR valve, a sensor that's seeing the position of that. That's another type 1. So this is your definitely your analog going on only on the positive side. So your 0 being at the bottom here, and then you can actually go up the scale again, like we talked about before. We can actually use that for figuring out if there's a defect in the position sensor. And then here's a typical oxygen sensor. This is going to be alternating current, but notice it's all above 0. So normally we have them somewhere between 0.1 volt all the way up to 0.9 volts on most of our sensors. And then we have this one here shows a mass airflow sensor. You can actually see when they actually snap the throttle, it actually seen the voltage try to drop just a little bit there. And then we have fixed digital pulse signals. This is for like your Hall effects, your opticals, LEDs, your digital mass airflow sensors, and your map sensors on Fords. So here is a Mazda, a crankshaft position sensor. You can actually see where it rises up to 5 volts square wave. So they use this 5 volts square wave. Here's another one on a crank sensor. This is, looks, perfectly fine. It's a fixed signal and it goes up to 7 volts on this one. It's still a digital square wave. And then we have your 3x, your 3 different crank sensor signals on this particular one. So it shows that 7 volt square wave signal. And then we have the pulse width modulated. These are going to be for like your ignition primary, your electric spark controls, your solenoid outputs. So this is a good example of an injector. This is that peak and hold type injector. It will actually peak, and then you'll actually see it snap and hold. And I'll be doing more on signals like this as we go along in the future videos and like that. This will change with the engine speed. And then we have serial data signals, like in your computer systems, that will actually send out information in packets. And this is a good example of a signal off of a CAN system. This is a 2.5 volt kind of range change. It can actually go up to 3.5 volts, and then you have that 1.1 volt that is actually back and forth. And this is what you might see typically on a CAN system like that too. So this is just an introduction to the different signals. We'll be breaking them down more, and I'll show you some bad ones as we go along, typically good, and then I'll show you some bad ones too. So that comes in a future video. So please like and subscribe if you enjoyed this, and I will talk to you a little bit later. Take care now. Bye for now.